Hello and welcome back. So in this tutorial, we'll be looking at another question, another theorem based on vectors. So what we have to prove is in this tutorial is that the diagonals of parallelogram bisects each other. So for the diagonals of parallelogram to bisect each other, we have to show that these two uh, diagonals should meet at a certain point, and also the length should be equal. So if this side ON has the same magnitude or the same length as side NC, and also BM has same magnitude as MA, we can say that the diagonals of parallelogram bisects each other. So this is the basic, and here to prove that, we have taken a parallelogram OABC, and here the position vector for point A is we have drawn a line from origin to point A. So OA vector, I've supposed it is equal to vector A, and position vector of point B is OB, and it is given by vector B. And what we have also supposed is that the midpoint of side AB is point M. So the midpoint of this diagonal AB is M, and midpoint of OC is this point N. It actually seems that these 2 points, they are same, but it isn't until we have proved that they are the same points. So at first we'll try to show that point M and point N are the same point, then we can definitely say that the parallelogram bisects each other. So this is what we have to show: point M and point N are same. So at first I'm going to take a triangle from this parallelogram, that is triangle OAB, and this is the midpoint of AB. So here is our vector A, and here is our vector B, and by the midpoint theorem, so this, since M is the middle point of line segment AB, we can say that this vector OM should equal to 1/2 of vector OA plus vector OB. So this is what midpoint theorem says. If you don't know what midpoint theorem is, then you can check into my playlist, and you can see that there is a video tutorial for midpoint theorem as well. You can see it if you like. So here 1/2 of OA, I suppose, is vector A, and for OB it is equal to vector B. So OM, the position vector for point M is OM, and it is given by 1/2 of vector A plus vector B. Also, if we look into the diagonal OC, so moving from point O to point C is same as moving from point O to A, and then moving from point A to C. Or you can also say moving from point O to C is same as moving from point O to B and then B to C. You can take any sides you like. I've taken the first one. So vector OC is equal to vector OA plus vector AC, and OA, we've supposed it is equal to A. And also, since this OABC is a parallelogram, so the sides OB and AC should be equal, since they are the opposite sides of a parallelogram, and they represents the same direction as well. So O to B and A to C, so they are moving in same upward direction. And for AC, I can substitute OB, since the vector are same, they have same magnitude, they have same direction. So for AC I can write OB, and for OB once again I can write is equal to vector B. Also, what I know is that N if I look into this triangle OCAN, N is the midpoint of this diagonal OC. So since N is the midpoint of diagonal AC, we can say that ON, so moving from point O to N, is half of moving from point O to C. We're considering the length here and the direction is same. So 1/2 of, we know that OC is equal to vector A plus vector B. So we have here vector ON is equal to half of vector A plus vector B, and also OM is equal to half of vector A plus vector B. So we know ON is equal to OM. So these two vectors are equal. Since the position vector for point N, that is ON, and position vector for point M, which is OM, they are same, the points M and N must also be same. So due to this reason, we can say that the diagonals of parallelogram, they bisect each other. I hope it is clear to you, and thanks for watching.